So digital fabrication, marriage of tradition and innovation. So what is digital fabrication? Digital fabrication is you take a 2D or 3D input from a computer and output it into a digital fabrication machine such as a CNC, 3D printer, or laser cutter. So traditionally, if you want to cut 100 pieces of something, you would have to use a traditional machine to cut it out of a bigger piece. Keep on cutting it over and over and over again until you get the right amount, the right size. So it's very labor intensive, very hard work. But imagine if you were to just output that information into a machine, like a CNC or a 3D printer, and that machine would just do all the labor for you, saving you time, saving you labor, and it'd be exactly as you designed it on the computer. So the history of digital fabrication started out in large-scale factories, mass production of goods and stuff. So some of that stuff is the chair that you're sitting at, or the table that you're sitting at, or the clothes that you're wearing, the utensils that you use. Those stuff are mass manufactured, a lot of it through digital fabrication. So in the past 5 to 10 years, smaller architects and designers like myself are starting to spread the idea of digital fabrication. So one of the biggest things in digital fabrication is 3D printing. It has the biggest range of audience, how many people use it, and what kind of use to do. So this is me doing a 3-day class in Yaosu, the town that I live at. So I went to the local elementary school, and then I taught kids about 10 to 12 years old how to 3D design. So I gave them kind of an open suggestion. You can design whatever you want. So they designed characters on a 3D program. And within a couple of days, they were able to design. And then the next day, they were able to 3D print their design. So imagine as a young kid, 10, 12 years old, you design something on a computer. First in your head, then on the computer, and then in the next couple of days, it's in your hand. And you can touch it, you can feel it, you can play with it. And so on the other spectrum is industrial design. So industrial design very complex shapes. So take this shape, for example. It's very complex. A lot of angles, a lot of holes, a lot of degrees. And to do this, to make this in the traditional method, would be very time consuming, very labor intensive. And the end product, you don't know if it's exactly how you designed it. Some of the degrees might be off, some of the holes might be off. But today, industrial designer could design it at the desk and have a 3D printer right next to them and 3D print it. And once it's done, they could analyze it to see every aspect of the design, if it's correct, what do they need to change, and how does it look. Some of the other aspect of 3D printing is not in the medical field. So doing prosthetics, doing 3D organs, doing tissue. So imagine that you lose the ear in an accident, and then that doctor is able to 3D print some ear for you, and then they're able to grow that tissue around the 3D printed object, and now you have a new 3D printed ear. So people have been designing for a very long time, 3D design, and these 3D designs get uploaded to some kind of online library. And now with the advent of 3D printing, people could just go online, download whatever they need, whatever they want, and they could print it out in the house. So the first group of people who really started doing this was hobbyists. So if you have a hobby, you probably love that hobby. So say that your hobby is anime. So a lot of anime fans will download anime characters and start printing them out. Or say that you're a cyclist. Say you need something for your bike, but there's nothing available, but you're able to find it online. Somebody already designed it, so you download it and 3D print it yourself. Or say that you're a baker. You want to bake some kind of form, something different, but that form doesn't exist. So you have to go online, either do the design yourself or find it on these online resources. So because of this idea of being able just to download anything and 3D print it, the market became really big, and so more industries are adapting it, and also in your everyday life. So architecturally, so a lot of architects do this here. So imagine that you design something a little bit more complex. So if you have to make this by hand as a model to present to your teacher, this might take you a whole day to make. And this might not end up the way you want it, because to cut all the small pieces, put them together, and then try to create what's on the computer is very time consuming and very hard. So if you already have that model in 3D space, you could just 3D print it, present it to your teacher as the thing that was inside your head. So now lately, in the past couple of years, woodworkers like myself are starting to use 3D design, 3D fabrication into their work. So this picture on the right is a very complicated drawing. So almost all the woodworkers I know cannot make this kind of drawing. Or if they can, they're probably expert. They've probably been doing it for like 10, 15, 20 years. But even just to make this for them would be very time consuming and very tedious. But now I could just go online, take this data, 3D print it myself, and put it into one of my furnitures. Or take this bench. So each slice has to be, imagine that you did this by hand. You have to manually cut each slice, and each slice is conformed to the next slice. So everything has kind of have to gradually match each other. But if you have a CNC machine like me, you could put a board down and cut one piece, maybe 5-10 minutes for each piece, versus an hour for each piece. So this is one of the cabinets that I did for a local architect in the office. So we want to use local material, such as hinoki and sudi. So the base was designed by 3D parametric. And then because each slice is different, we have to use a CNC. So the CNC was able to cut each slice, and we were able to assemble it to kind of get this kind of unique facade. So now 3D printing is kind of in everybody's life. So imagine that you're living in a city, but you want to have a garden, or you want to do some kind of farming, but you're restricted. So one of the ways to overcome that is go online and buy these 3D planters. So each stack holds about three plants. So one stack could hold about 30 different plants. So imagine you just have one stack, you have 30 plants, and then you just have a row of them. Now you have your garden in an urban space, so it's kind of addressing an issue of urban farming. So some people are natural designers, some people are natural builders, some people are just natural problem solvers. So 3D printing kind of blend all of them together. So you have a problem, you want to hang your vacuum on the wall. There's no product out there, but if you go online, there might be one that you can just download and print yourself. Or if you're just a natural designer, you want to design something, same thing. So there's a lot of places that kind of cultivate these kind of ideas in these people. So there's places called Fab Labs or Fab Cafe, Maker Cafe, Maker Space, sorry. So you go there with an idea in your head, but you have no ability to make it. So these people will help you. They will help you create something on the computer and then digitally fabricate it, either do laser scatter, 3D printing, CNC. So I also open my lab to these kind of people. If people just want to come in and try and learn traditional machines, that's great. So they will come in, and if the idea is too advanced, then I will bring them to the computer, and then we will 3D design something and put it into the 3D printer or laser cutter, or again, the CNC machine. So when we talk about craftsmanship, we think of making something with craft, hands-on approach, how beautiful it is, the end product. So with digital fabrication and craftsmanship, how do they blend together? We have to think about the different roles of the human, like the human role in making this, the computer's role in designing this, and the digital fabrication role in producing it. So if you take a closer look, we can kind of really see the details, the craftsmanship. So maybe the craftsmanship for the digital fabrication tool is down here. All the holes, so the holes make the structure lighter, but it doesn't take away from the integrity of the structure. It's still very strong. And then the top part, the wood top, is that made by hand? Is that made by digital fabrication? It could be both. It could be my input and the digital fabrication's input. And then as a designer, how do I marry the two together? How do I take a 3D printed part and make it something beautiful with a piece of furniture? So design could start out really simple. So on the right side, it probably started out as a simple sphere, and over time got more complex through various design methods. So now it became so complex that the only way to make it is through digital fabrication. Or you take the lampshade, for example. Parts start out as a very simple shape, and over design iteration, it becomes more complex. And again, the only way to kind of create it would be digital fabrication. So one of the big topic is SDG. So as a creator, as a designer, as a digital fabricator, it's not really integrated for sustainability, but as time goes on, we are becoming more and more aware of sustainability. So one of the sustainable things are taking PET bottles. We all drink PET bottles. They're all on your table. We take the PET bottle caps, we grind it up, turn it into filaments, and the filaments turn into a 3D printed part. And then, if that part is not what you want, you just re-grind it up, and you put it back into a filament, and you make a new one. So, but for me, I always had sustainability in my background since my education. So when I renovated my house, my IKEA, I took all the wood. I kind of kept most of what I could, and I turned some of them into a planter, some of them into a tray. The tray was made from a staircase inside my house. And then I needed some lights. So I went to the recycle center, got cardboard, put the cardboard into my laser cutter, and I just cut out each piece. So as a series of cardboard, I made some lampshades. And then, so my place is surrounded by the forest. So Hinoki and Sudi is big in my place. These stumps were going to get tossed out. They can't sell it, or they were going to be turned into firewood. I say, please give it to me, and I turn them into something different. So due to some 3D design, I was able to make some polyhedron stumps. And then this as well was going to be tossed out. You can see the crack forming inside the stumps. So I took it from the left side, put it on the CNC, and the CNC did everything. It made it flat, it made it parallel, and then it made the ribbons within the crack to keep it from cracking even more. So all this was done by a CNC machine. So what I want to end with is that whatever you guys have inside your mind, if you guys want to make something, you guys can make it. doing digital fabrication, 3D printing, laser cutter, or CNC. Thank you for your time.